Have you ever wondered how meteorologists know if it will rain tomorrow or next week? It sometimes feels like magic, but there is a powerful science working behind those daily forecasts. Yes, computer models can absolutely predict weather, and they are incredibly sophisticated tools that form the backbone of nearly all modern weather forecasting. While not always perfect, their accuracy has improved dramatically over the years, giving us better insights into what the atmosphere has in store. The core mechanism behind these predictions is called numerical weather prediction. This involves taking current observations of the atmosphere, like temperature, pressure, humidity, and wind speed, and plugging them into extremely complex mathematical equations. These equations describe how the atmosphere behaves based on the laws of physics. Supercomputers then solve these equations to project how these atmospheric variables will change over time, creating a three-dimensional simulation of future weather conditions. However, the atmosphere is a chaotic system. This means that tiny, unnoticeable differences in the initial measurements can grow into significant forecast errors over several days. This is often referred to as the butterfly effect. Because of this inherent uncertainty, meteorologists do not just rely on a single model run. So, how can you best use this information? Always consider that shorter-term forecasts, typically for the next 1 to 3 days, are generally more reliable. As you look further out, say a week or two, the forecast becomes more about general trends and probabilities rather than pinpoint accuracy. It is also wise to look at forecasts from various sources, as different models might produce slightly different outcomes. To tackle this chaotic nature, meteorologists use a powerful technique called ensemble forecasting. Instead of running just one model, they run dozens of slightly altered versions of the same model, each with tiny variations in its initial conditions or its representation of atmospheric processes. This creates a range of possible weather outcomes, which helps forecasters understand the level of uncertainty. If many of the ensemble members predict rain, the confidence in rain is high. Another exciting development is the increasing resolution of these models, meaning they can now depict smaller, more localized weather phenomena with greater detail. By understanding that weather forecasts emerge from these intricate computer simulations, and appreciating their strengths and inherent limitations, you can become a more informed weather watcher. This knowledge empowers you to plan your activities more effectively, whether it is packing an umbrella for an afternoon shower or preparing for a significant weather event, with the confidence that science is on your side.